So what's poppin', everyone? So in this video, I'm going to tell you 8 ways you can improve the quality of your code. All right, way number 1 is to have code reviews. So you have to review the code. There's no way it's going to get better without you looking at it, looking at the code you did and seeing what could you improve. So if you're on a team, you can have regular code reviews where everyone can review each other's code and things will not go into production. Things will not go through the pipeline, or however, whatever, if you have a pipeline, without the code review actually happening. So this will be something like at least one review, like one approval is required for the code to advance through to the main branch if you're using Git. Not everyone uses Git. But so you should even do code reviews for like high up people, like senior developers, because they make mistakes too. They're not perfect, and sometimes they'll miss some semicolon or something from time to time. Some easy things to look for while you're reviewing your code or someone else's code is look for code that is unreachable. So obvious logic flaws, and sometimes like even editors will show you, hey, this code is unreachable. You have like something after you return something. So if something can't execute, then that's a pretty obvious logic flaw and should be an easy fix as well. So number 2, the second way you can improve your code is you can use, or you can stop using old libraries like PHP and JQuery and start using the new ones, of course, if you're not. Instead of like jQuery, you can use React. There's Angular. There's Vue as well. Those are good front-end technologies. And if the library was made a long time ago, so what's a long time ago? Maybe like at least 5 to 10 years ago. If it's older than that, then definitely it's probably getting old by now if it's an old library. That doesn't mean every single old library is bad. Of course, there's ones that are very old. They get updated very often. But if it's really old and doesn't get updated like very often, like it hasn't been updated in like years, then yeah, maybe it's time to look for a newer library. And sometimes like they might be updated like a little bit for like minor security flaws and stuff like that. In which case, yeah, it's not really updating the functionality. So number 3 is kind of like the opposite of number 2, and it's that you want to use libraries for common tasks. Because why would you want to reinvent the wheel? This is for like something that has been done a million times before, and there's a library to do it, and the library has some complex logic in it, but it gets the job done. And you can either choose to implement that complex logic, the complex implementation of whatever you're trying to do, or you can just use something that has already been done before. And this might like reduce the quality, or it might improve the quality of the code because this thing's been done so many times before. It's probably been improved upon as well so many times before. So why not use the better thing? And why not just do it? Use the good code. All right, number 4 on my list is using too many libraries. So this is kind of like you either use the old stuff, you use too many, or yeah, you can use too many. So of course, the thing with using too many libraries though is like you're trying to use a library for every single thing in your application. And there are flaws to this, even though the libraries might be very good, they might solve every single issue. It's just you don't know everything that's going on behind those libraries. Like some of these libraries might slow down your application instead of you doing it by yourself. Like you have to really think for each time you use a library, would it be faster if I did it myself? Would it be easier if I did it myself? Because sometimes a library can be difficult to use because you have to understand the ins and outs of it. And then there's also the fact if someone else is working on your code, then they're going to have to learn the library because you have to like look at the library. You can say, oh, you're using Lodash for JavaScript. Well, you have to understand there's a lot of different functions in Lodash, so someone might not know every single function. So you have to also keep track of these libraries sometimes, because sometimes these libraries get updated, and then they might add new stuff that you might not realize, or they might take away, well, usually they don't take away, but they can take away stuff from the libraries. But of course, you can version it to do a specific version and whatnot. But yeah. Or number 5 on my list is writing too many comments in the code or not enough comments in the code. So for example, you want to write comments for very complex code that needs explaining. So what needs to be explained? Well, maybe there's some complex logic that used a certain type of algorithm. Like there's many different algorithms, but you can say, oh, that's this algorithm, that algorithm, and you'll immediately know what that is. But sometimes there's different ways to implement the algorithm. So that's why you kind of want to comment it, maybe use a very popular algorithm. But other times, good code that's not using a complex algorithm will speak for itself. And you don't really need to leave a comment for each function, each variable name. I use this variable because this reason, and this function does this and this and that. And then it's kind of, you'll eventually have more comments than your code. And then you're reading essays in the code, and then you write novels in the comments section. And but yeah, it can get a lot of comments. So you don't want to use too many, and you don't want to use too much. You kind of need to get some, once you practice it, you should know when to comment and when not to comment. All right, my number 6 tip is to look for time and space complexity. So can you use a different algorithm that gets the job done with less space or is quicker? Instead of order n squared, you can get it done log n or something like that. So you have to really pay attention to loops and stuff like that. Or if you're using some other algorithm, there's many different ways to look for time and space complexity. But of course, if you have better time and space complexity, you have better code. That's kind of how it works. Of course, there can be trade-offs. You might trade more space complexity for less time, or more time for less space. And that's where you have to really think of the business's needs here. Where is this code being run? Is it being run on a server in the cloud, or is it being run on the client side on this person's machine? And then we're going to ask who's using, who's running this client side? Is it people with really good machines, or is it people with iPhones from 3 million years ago? So in that case, you would probably not try to have all your logic to be on the client side. All right, number 7 is to have code formatting be a part of your build. So you want to have your code be formatted properly and look all pretty and spaced properly. And because nobody will want to work on your code, or you will not want to work on your code if it's not formatted properly. And if the code base, nobody wants to work on the code base, it'll eventually become a dead project because no one wants to work on it, even if they're getting paid to work on it, until the code is reworked, many years down the line, and then it'll just become a dead project. So another thing you might want to add in your build process is to check for test coverage. If your test coverage is too low in the build process, then you want to stop everything, and then give the warning or error saying, hey, your test coverage is too low, you need to fix your tests or whatnot, and come back to me when you're done. So my final tip is kind of an obvious one. It's to look for edge cases that might produce bugs. You might say, oh yeah, I don't make any bugs. And then, yeah, you might be right sometimes, but there's always edge cases that might come up, and you might want to look into them. And you might not want to fix them every time, because there's always going to be an infinite number of bugs, or maybe not infinite, but near infinite feeling number of bugs. So for example, you might want to look at cases is every user allowed to see this new functionality? You have a new button, can everybody click that button? If not, then that could be a potential bug. Someone's allowed to click it who isn't allowed to. Or someone clicks it, but they're not allowed to, so then that's a security issue, so potentially. So you might want to think through the user's brain, because you're not the user. You're going to think differently from them, because you're coding this, and you're going to think logically. But the user is going to think they want to just get the job done. They're not thinking logically. Sometimes, not everyone is. But users might think differently than you are. So you want to think through the user's eyes, put on your user eyes, and think how they're going to move through it, and how the cases that they're going to use the application for. So oftentimes, things that you might be looking for users won't even go through. So fixing that kind of bug, It's kind of a waste of time, because if user's never going to get there, then what's the point of fixing it, right? Just send that off to a junior developer to fix. And don't spend your too much time trying to fix these very rare edge cases that barely any user will experience, unless of course it might cause a security flaw. Well, anyways, that's the end of this video. Thanks for watching. Make sure to like the video, comment, and subscribe if you liked it. I'll talk to you later. Peace.